Okay, so for this question, what did y'all do? Did y'all try to get the same common bases?
Yes.
Alright, so how we do that, y'all probably already know, is 9 would be equal to 3 to the power of 2, and then 27 would be 3 to the power of 3, and then you multiply it with the exponents that already exist. Cancel these out, and then that would be 2a plus 4 equals 12a minus 6. And then you continue on from that. And did y'all get a equals 1?
Yes.
Okay.
Nice.
Bueno. Now, what if common base is not possible? You remember that?
Yes.
Okay. So you apply that for this. So this 2x would turn into log base 2, 2x, and then you cancel this out, and then you put the log base 2 here. Sorry. And then your answer would just be log base 2, 61. But then you have to put this in the calculator, because this is like not complete. So put this into your calculator and see what you get.
Wonderful. Did you guys get that part?
Yeah.
All he did was just take the log with the base 2 on both parts. So those cancel. You're left with x, which is what he wrote, x, and log base 261. Log base 261. All right? All right, when you got it, shout it out. Let David know what you got.
5.93074.
All right, thank you. Okay. So for this one, this has the exponent, so you would turn this into log base 8, and then you put log base 8 over here. So, and then this will cancel out, but this stays because like they're not equal, and then you would get n7 equals log 8, 92. Right? Now, you want to get the m by itself, so to do that, you would add 7 on both sides. This will cancel out, and then it would be 2 minus 7. Now, do not add these together because, wait, what?
Plus 7?
Oh, sorry. Do not add these two together because the log 92 is a part of this. Yeah. And then
9.17.
you said what?
9.17.
All right. Thank you. Okay. So for this one, you need to try to get this part by itself first. So to do that, you need to subtract 10 on both sides. This will cancel out. I'm gonna go over here. And then you still have the 3 times this part. So you need to divide it. And then this will cancel out. And it'll go over here. Okay. And then now you still have 8 to the power of 3 minus 7n equals 94 minus 10 divided by 3. And you do the log base thing like we did before.
Wait, let's simplify that big old fraction.
Oh
What
yeah,
does that
sorry.
become?
28.
28, okay.
Okay. Then you add the log base 8 on both sides. And then these will cancel out, and then you're left with this. And we still need to get n by itself. So you would subtract 3 on both sides.
Bless me.
And then you still have negative 7n, so you would divide down on both sides. And then this cancels out. And I'm left with n equals this mumbo jumbo. Alright, now put that into your calculator and see what you get.
0.199.
Excellent. N equals 0.129. 9. Okay, class. If you remember from the previous activities, you'll remember the one-to-one property, and that is if log b m or log base b m equals log base b n, then n m equals n. So you cancel these out, and then you're left with m equals n. And this is important for this activity. So for this one, the log and the base is the same on both sides. So cancel, cancel. And then you're left with 1 minus 4n equals 2n plus 43. And then you just solve. So minus 2n, and then minus 1. And then you're left with n equals -7. Okay, did y'all get that?
Yes.
Alright, so that's easy. Now this one. Okay. So the bases are the same here. So again, cancel it out. And then you bring these down. 2w. And then you solve it regular. Plus 3w on both sides. Cancel it out, and you're left with 6 equals w. Now don't box your answer just yet, because you have to check for extraneous solutions. So with extraneous solutions, if we remember the log function, which on a graph would look something like this, remember that there is an asymptote and that the line doesn't actually cross into the negatives. So extraneous solutions would be, so like the answer would have to be not a negative. Sorry, my handwriting's not that good. And it shouldn't be 0 either because of the asymptote. So extraneous solutions would be negative and 0. And how to check for extraneous solutions is that you plug this number into here. And if it ends up being negative, or if it ends up being 0, then it would be an extraneous solution. So then let's see it. 6 minus 3. This would equal 18. And this equals -12. So 6 would not end up being an answer. So this has no solution.
All right, thumbs up if that made sense. In the middle if you're a little unclear. Down if you didn't get it. Show me your hands. Okay, so guys, y'all solved it and you got W is 6. If you plug it back into here and you get a negative or a 0, it's not an answer.
So you only plug it into one of them, not both of them?
You can plug it into both. If either one gives you a negative or a 0, it's not an answer. Yes?
So even if, like, let's just say that W is equal to -4, but the answer after plugging in is positive, it's still a solution?
Yes. Great question. Say you solved it and you got W is -4. Even though your answer is negative, if you plug it back into here and it's not negative or 0, then it's an answer. What he was saying here is if you draw the log graph, notice there's an asymptote right here. So there should be no zeros in here because you have an asymptote at 0. Also, if you remember the log graph, there's no negative side. So you shouldn't have negatives or a 0 when you plug it back in here. Does that make sense?
Yes.
Okay, great. Go ahead and move on.
Okay. So for this one, you have to condense it first. So let's go over here. Let's input the product property, if y'all remember, or the power property, if y'all remember that. You would bring this to over here, and then this would turn into log base 3 equal 36, and then we still have the subtraction sign, so this would be the quotient property. So then you would do, well, I would say cancel these out first, and then 36 divided by 4 is just equals 9. So then you're left with, oh, and then cancel this out too as well. You're left with 2p minus 5 equals 9. And then you solve. So plus 5 on both sides. Cancel out. 2p equals 14. And then you divide on both sides. And then p would equal 7. And again, you still have to check for extraneous solutions. So plug this in, and someone tell me if this is a solution or if it's not.
Solution.
It's a solution.
It's a solution? Alright. Good. Did everyone get that or understand it?
Yes, ma'am.
Great. Let me just go back for 1 second. This became log of 9 with the base 3, because 36 divided by 4 is 9, and that equals this log, and then those canceled like that.
Oh, my
That's
bad.
why he said those.
Oh, sorry.
Very good. Okay.
My bad, Joe. Okay.
Is he gonna be on YouTube? He's gonna be famous.
Okay. So for this one, we have to condense this. So the product property, this will equal to log 2k squared. And then you just bring this one down. Then of course, since the bases are the same, we cancel these out. Oops. Then you solve. So you subtract k squared on both sides. And now to not get this like confused, this wouldn't equal like 2 or something like that. This is just 2's k squared minus 1k squared. So this would just equal to k squared. And then you have your 16 over there. And now to solve this, you have the square root both sides. And with the square root, there is going to be 2 answers. One positive, one negative. So when you square root 16, you'll get k. And then you would get a positive 4 and a negative 4. Okay. Now we're not done yet, we still have to check for extraneous solutions. So for 4, is it a solution?
Yes.
Yes.
Okay. Now what about for negative 4?
Yes.
Yes.
So both of these are solutions. Okay, we're good. For this one, instead of log equaling a log, log equals a number. So instead of using the previous rule that we used, we'll use this one. Y'all remember this? And then you would cancel these two. You would first have to isolate the log. So you would add 7 on both sides. 4. Cancel these out. Equals log 3 4x plus 8. Now you gotta take the base here, put it down here, and then you do it for here as well. And then these will cancel out, and then you'll get 4x plus 8 equals 81. So not waste time, you don't have to like rewrite the entire equation just to put the 3 down. You can just put the 3 right there, and then put the 3 right there as well.
Oh, I can.
Yeah. And then you will solve like normal. Subtract 8 on both sides. And then you cancel these out. You'll get 73, or 4x equals 73. Now, can someone put this into the calculator and like tell me and stuff? Okay, thank you. Look at 18.25. And for this one, we still also have to check for extraneous solutions. So can someone tell me, is this a solution or not?
It is.
It is.
Okay. Nice. The bases are the same, common log, but you need to condense it. So you would product property this, and then you'll get x squared minus 3x equals 1. And then since a common log means that this is 10, you would put a 10 down here and a 10 over here. These will cancel out, and then you'll get x squared minus 3x equals 10. Now if you notice something different, this has a square on it. This is a quadratic. So you would have to make this 0 by subtracting 10 on both sides. Okay. Right. Oops. Yeah. And then these will cancel out. And then there's your quadratic. Now to solve, what can you do?
Very, very good.
And then very quickly, someone tell me what the x's would be.
Negative 2 and 5.
Are any of them extraneous?
The 5 is. The 5 is. So the answer is negative 2.
The negative 2 is extraneous.
Wait, no, be.
Yeah, so the only
never mind,
solution
yeah,
is
never
5.
Yep, the only solution is 5. Nice.
And all that, doing all that